Up until now, you've been using variables to store individual pieces of data for your programs. But as your programs grow in complexity, you're going to have a lot more variables than you can really manage. Let's start with an example. Let's assume you're writing a program that lets a user enter in overall homework scores. They enter in some number of homework scores, and then at the very end, you give them an overall average of how they did. We already know how to do this with some variables and a for loop. As you loop over however many homework scores are going to be entered in, you store whatever is given to you into the sum variable. Then at the very end, the average is just the sum divided by the count of homeworks. Simple, right? Well, what if you were also asked to tell the user how many of their homework scores were above that average? That means that you're going to have to evaluate the overall average in comparison to each individual homework score. But this solution doesn't let you do it because you sort of forget whatever they gave you as soon as you go on to the next thing. You only have one variable for all the different homework scores. Here's how you might solve it with individual variables. Not the prettiest code. As you can see, we have separate variables for each individual homework assignment, which does technically work. But what if you were asked to do this for more than 7 homework assignments? What if you had to do this for hundreds of homework assignments? Managing all those variables independently would be a nightmare. And what if you wanted to give the user the flexibility to enter in how many homework assignments they wanted to evaluate? That is not possible with this code. It's very static. But thankfully, there's a tool to help you solve both these problems. Meet the array. The array is a data structure, which means it's a collection of the same type of variable all under one name. Here's how you might visualize an array. It's a long block of memory that's split up into individual sections where you can store individual variables. So here we have an array of ints, and we can actually store 10 separate ints all within the same variable, the array variable. Arrays comprise 2 pieces. They have the elements, which is the data itself, and then each element is given an index. The index is sort of the address of where your element lives within the context of the array. So for example, if I wanted to pull out the very first thing in the array, I would ask for the element at index 0. Yes, arrays start counting at 0. Don't worry, you'll get used to it. Let's say we wanted to pull out the element at index 4. That's actually the 5th thing in the array, but the computer knows exactly where to look. And then finally, if we wanted to pull out the very last thing, we would ask for the element at index 9. So by using these numbers or addresses, we can find anything directly in the array. Here's how you create an array. It starts with the type and then a set of square brackets. And then that very special keyword new, meaning this is an object. Then you have to give it a length. How many things are you going to store? Here's an example. An array of 10 integers. There's 10 different spaces, and you can store up to 10 different or exactly the same integers, whatever you like. You can store lots of different things in arrays. You could store doubles. Here's 7 different doubles. Or you could store a bunch of characters. In fact, arrays can store anything that you want. Keep in mind, though, because they start counting at 0, the very last index in the array is always, however long it is, minus 1. Here's how you access or modify each individual space in the array. You use the name of the array, the square brackets, and then in between the square brackets, the index you want to pull out or change. So if I wanted the computer to give me the homework grade at index 4, I would say homework grades, the name of my array, square bracket, the number 4, meaning its address. If I want to change that exact place to be 2, then I use the same syntax. I just set it equal to 2, and it totally evaporates whatever was there before and replaces it with the number 2. When you first create an array, it doesn't have anything in it. So Java picks some 0 values. Most of them are very self-explanatory. The int 0 value is 0. The double 0 value is 0.0. But if you're storing objects in your array, your 0 value is something called null, which is a special value that just literally means no object. Here we construct a brand new array of 10 integers, meaning we have 10 spaces for ints, but you have to actually fill it up. And before you do so, it looks like this, just 10 zeros. Arrays and for loops are best friends, and that's because for loops come with their own built-in variable, and this variable typically counts up from one number to the next, meaning it's a perfect way to count from 0 up to however many things are in your array. Here's a couple examples of how you would do that. This case, I represents each individual index within the array. So you'll see a lot of syntax like this, where you have the name of the array, square bracket, I, and then whatever you want to do. To make these even more dynamic, you can measure your for loop test based on the length field that comes with an array. So here we have a classic example where we have a for loop starting at 0, the first thing in the array, and then it goes up till strictly less than the name of the array dot length. This is going to return back however many things are stored in the array. Just one thing to note, length happens to be a field, so you always use the name of the array dot length, no parentheses. Let's go back to our original example. Here is our homework grade calculator. And here's how we solve it with arrays. We start with an array at the very beginning, and it's going to store each individual homework assignment as the user enters it in. So as we go through and ask the user, hey, what'd you get on this homework assignment? We update the element at I within the array set equal to whatever they pass in. And because the for loop starts at 0 and then counts 1, 2, 3, 4, so on and so forth, then we'll start filling up the element at index 0 with the first thing they pass in, and then the element at index 1, and so on and so forth. Once we get to the end of that for loop, now we have an array filled with integers. So we can go back through and look at each individual one compared to the overall average. And that's where we finally get our count of how many homeworks were above the average grade. Arrays are so important. They're the foundational building block for every data structure you're going to learn. So mastering them now is going to save you a lot of heartache later on.